What's happening, YouTube? Welcome back. On today's topic, we'll get straight into it. This one is going to be a continuation, part 2 of the span and the RSPAN video that I did previous to this one. I'll link it in the description. And this lab, hopefully it won't be too long. I'm going to try to make it as short as possible, but this one is a little bit more difficult because instead of how we did it before with span was first with span we did it on the local switch. We did the monitoring or the mirroring of the traffic from a monitor port on a local switch, and our analyzer or our sniffer or switch port analyzer that was connected to the network was right there on the local switch. That was span, and that was pretty straightforward configuration and verification, as well as remote span. This time when it's on a completely different subnet or network, so we're going layer 3 on this one with ErSpan. I'll just bring up all this topology and then we'll go from there. So right here, I could make this bigger, I guess. What I'm gonna attempt to do, we got a MacBook right here that I'm on right now. Then I have another Windows PC. This is just a screenshot from GNS3 because I just wanted to build a topology for it. So we have WireShark running, which is a sniffer or a analyzing tool. And then that's on a Windows PC. And what we're gonna do is, even though there's a subnet 20.1.0 here and for my MacBook, and then WireShark has, or this PC is on subnet 10.1.1.0, we're gonna monitor the traffic from this guy and mirror that monitor traffic so that WireShark can see it all the way on this guy. So that's kind of what we got here. So this right here would be R2, as you can see down there. So R2, we're gonna configure that. First we'll just show, and as you can see, we got those ports, gig 000, that's the .7, 192, 168. You can see the rest, 20.1.1, that's this guy. So we could just jump straight into the ErSpan configuration. And for this one, we're gonna, just to make sure, because I was practicing this lab before, make sure there's nothing on here. Moving forward, we're just gonna go on the configuration mode. And then I'm gonna have to question mark my way through it, so y'all bear with me as we are learning together. I'm not no pro at this. So we can make the monitoring session just like before on span or ErSpan. You can make it anything. We'll just make it something simple, number 1. And then the only difference here, I'll show you, is you have type. Now you can set type to ErSpan source or destination. Since this is the source down here, that's what they mean, the source. That's the hardest part of this whole ErSpan concept, or this whole ErSpan thing. Can't think of a word, but the source and the destination, it's just trippy until you really work with it. It's kind of like it throws you off or whatever, but we'll just push through. So ErSpan source, feel me, source, if I can spell it. And then that puts you into span mode. And then what you want to do here is source what? Source interface. And that's going to be that gig 0/1 interface. And then, and whenever you're running this, for whatever reason, you have to no shut the session as well. Don't forget to do that. Then I believe now you could specify the destination and the properties of that destination. So source, I'm pretty sure that that's all finished, but we'll find out together. So source, then destination, and that puts you into this different level here. So you're in ErSpan source, you're still on the source, but you're specifying destination properties pretty much right here. And those destination properties are the same like RSpan, where you have to specify a VLAN to go over the trunk for the monitor traffic only. ErSpan, you have to specify ID. Now this ID is used as a unique identifier so that if there's multiple span sessions, the routers know which ones to communicate with and whatnot. But it also is a tunneling concept. I don't understand the tunneling concept that great, but this whole lab I put together, shout out to Kevin Wallace. He's a trainer on YouTube that I follow, and I hope he doesn't mind, but pretty sure I don't got a lot of subs, so I'm pretty sure he won't mind. But this is a lab that he did, and I just plugged in all the same stuff, but just built my own. But just used his and followed along in his video. So definitely check out his video. If you resonate with him better, or if you just want to learn better, definitely check out other resources when you're learning. And that's what I did. And that's what I'm here for. I'm trying to be another resource another trainer out here. So moving forward, span ID, we'll just say that that's going to be, we'll keep it simple, number 1 as well. So now you're going to have to put IP address. The IP address you want to put here is 10.1.1.2. That's going to be the IP address of the actual device that is running your sniffer analyzer program. In this case, it's this Windows PC at .2 right here. So you put that, and then here you're going to have to put the final part of the config is origin IP address. This is part of that tunneling concept. So origin IP address, this is going to be the IP address of the interface that is pointing to, or that can get to, your destination of 10.1.1.2, or that can get to the other network. So that IP address that knows how to get there is gig 000, which is the 192.168.1.7 IP address. So that's your origin IP address. I don't know why they use the word origin. It kind of throws me off, but just know origin is your egress interface for where you want this traffic, this mirrored traffic that you're mirroring here. If you want it set out here, if I had it over here, gig 002 over here, right? And that subnet was pointing to this subnet, or where the actual device is, I would point it out that guy to get over here. But that's not the case. This is how he gets there, and that's why it's origin IP address, and that completes the source configuration for ErSpan. We'll go over to the destination, but I do also want to include that when I built this, I had to put in a dynamic routing protocol. I used OSPF because you have all these different networks. So again, how do I know how to get to 10.1.1.2? I know how to get there because I'm learning that route via OSPF from my neighbor 192.168.1.6. So again, that's why the origin IP address, actually let's verify this, session 1. That's why my origin IP address right here is 192.168.1.7, because that's the only link, or the only IP address that knows how to get over to the 10.1.1.2 destination IP address. Now let me go ahead and bring up right here. This is router 1. Sorry, get all of this out of your way, and we're going to configure this. And this is going to be monitor session 1. Keep the same. Monitor session 1. Type span, but this time you're going to put, as you guessed it, destination. Let me make this bigger for y'all so you can see real quick. Oh, my bad. Well, my bad. Hopefully it's big enough. Sorry. And then we'll just keep going. So monitor session 1, type ErSpan destination. Again, you got to no shut down this feature again, or to run this protocol. Sorry. So you no shut that, and then the destination you're going to use here. Destination interface gig 0/0/. Let me go back to my diagram right here. So I'm on R1. This is the destination right now. So what I'm telling the router right now is that I want, just like I had to have the source interface for the mirrored traffic, I got to have a destination interface for that mirrored traffic. And the destination interface is not going to be this guy. It's going to be this guy, because that's where I want that traffic to go. So destination interface is gig 001. Then the next step is going to be source. So just like how we put destination when we were on the source router, now that we're on the destination router, we're going to put the source properties now right there. Maybe this thing even says source properties. Yes, specify source and their properties. So if you're on the destination, you have to put the source properties, and if you're on the source, you got to put the destination properties. So source, that drops you down into that sub level of destination source. Make sure you know that you're in that sub level there of the configuration. And once you're in here, you start specifying all of those properties. What's the ErSpan ID? It was number 1, because we're keeping it simple. Now here, all you have to do now is just specify the IP address of your protocol analyzer or the sniffer, which was 10.1.2. Again, all I did was specify the source properties, meaning the ErSpan session ID, so it recognizes that, and then the IP address where I want all of that traffic from my source to go to, and then that's it. And then you hit end, that's the configuration part of it, and we're verifying it here. Session 1. Again, this is a little bit different than the RSPAN and SPAN video, but when I verified it there, it had different output here. This type is an ErSpan destination session, admin enabled, because I did a no shut, so make sure to check that on your status. If you don't put a no shut, that might be another lab to do. I don't know what it'll look like. Never did it. Too scared to do it. Destination ports, gig 001. Again, where do I want it? I'm on the destination. What port on this router do you want this mirror traffic to go to? Source IP address. I don't know why they say the source is going to be where the destination is going to end up, but that's how it goes. And if I'm lying, I'm flying. But we're about to test this thing and it should work. So right here, couldn't clear this out, but you could ignore that. What I'll put here is a filter P. So if you haven't worked with WireShark, I'll give you a quick down and dirty. Right here is a filter, because I'll show you right now why you need a filter. With any protocol analyzer, continue without saving. If I just let this thing run, it's just going to capture all kinds of traffic on my interface. You see some OSPF traffic going on there. Give me 1 second, guys. So there's all this unwanted traffic right now. I just want to look for a specific traffic. And right now, what this is showing me is monitoring everything on this link right here. That's feeding into WireShark. If we went into there, Dell, that's my computer, that's the destination and everything. But let's go ahead and just clear this out. We're going to put ICMP. Oh, again, so that's why we want to use a filter. So if we put ICMP, that's a filter and it's a keyword for WireShark. And also, I just wanted to include with WireShark that there's different panes. This is a pane where different window panes. This is where the traffic is being captured. Here, these are all the packets that are being captured. And then here is where you could break out the different details of each of the packets. So there's the MAC address information, then you got the source and destination IP address information. So again, the main point is that I wanted to get across was that you have to filter when you're doing any kind of packet tracing, because, or not packet tracing, sorry, when you're using WireShark or doing any sniffing, because you're just getting a lot of traffic that you may or may not want. There's 95 packets and they just keep going. So also, when you're typing this, it does help you out, because again, you see it shows you're on the right path. And then also you see the color change to green from pink. Pink means you got the wrong syntax. Green means you have the right syntax. Hopefully that helps. I'm gonna stop this capture. And after you put the filter in, you have to apply it with that. I don't know why all that's there. So let's go back. Hopefully let's do this. Clear that out and stop it right there. And then we'll start it again when we let me go get back to the screen here. All right, so right now the test is I'm gonna ping just over here, but that ping, we should be able to see it come up over here on a completely different subnet, because I'm gonna ping from my Mac PC over to that WireShark. So here's my Mac, it's hanging back there. Let's see, let me get that back. So ping 20.1.1.1, and just so you could see, grab 0. That didn't get it. IF config, let's just do that. Anyways, that's my IP address. I didn't know why it didn't show me before, but that's 21.1.1.2, and then I'm just gonna ping over to 21.1.1 to clear it. Ping 20.1.1.1. Let me bring up this sniffer so we could watch it as it happens. We'll bring this guy just like this, so we should see the traffic go over there. Let me start the capture, continue without saving, and then ping, and boom, we got it. So I'll stop the ping here and we'll pull up this a little bit closer. So here we go, that's a ping right there, 20.1.1.1 source. Oh, I'm sorry, here it goes. Let's look at this packet. So 20.1.1.2 is my machine, going to 20.1.1.1, which again was just the interface right there. So 20.1.1.2 source, going to that interface. Let's look at that packet a little bit more. That's what this lets you do. So again, the source and the destination is right there. But you also have a source of 192.168.17 and the destination of 10.1.2. And there goes that GRE ErSpan tunnel right there. Information letting you know it's an ErSpan packet, span encapsulated remote switch packet. More information on that. And then here, this is layer 2 information. The source, that's the Apple, that's the MacBook. Destination right there. That'll be my Dell machine over there, or the Windows machine. And then that's pretty much it, guys. Hope everybody learned something. I appreciate your time. And if you did like the video, please, as always, like, comment, subscribe. I'll definitely catch y'all on the next one. And you already know what time it is. It's Ninja Finish.